A traditional car wash uses up to 500 liters of water per vessel. Multiplied across Europe, that is an enormous burden on water resources. That is the problem this project addresses. My name is Ihsan Rauf Saraçlı, and this is my individual remedial presentation for the IPM course. The project is OnDrop EV, a pilot service that integrates a sustainable car wash into Tesla supercharger stations in Barcelona. I will present it through two lenses: sustainability and risk management. Three numbers to set the scale: 5 pilot modules, 52 weeks, 1 million euros. The agenda follows the standard IPM structure: 12 sections. I won't read the list. Instead, I have grouped it into 4 acts: why this project exists, how we plan to win, what could kill it, and how we deliver and close. Act 1 starts now. EV adoption is accelerating. Spain's EV share has passed 19%. Tesla's supercharger network is opening to other brands. But car wash infrastructure has not changed. Traditional washes use enormous amounts of water and operate completely separately from charging. So EV drivers have two problems at once: wasted water and wasted time. The answer is on the right: a wash that runs in parallel with charging, low water with recirculation, biodegradable products, wash cycle equal to or shorter than the charging station. The whole experience design hinges on that constraint. The mission: fast, minimalist, genuinely sustainable EV care integrated with charging. The vision: become the leading specialized EV washing service in Europe by 2030. The numbers on the left make the case: 50 to 150 liters for an efficient wash, up to 500 for a domestic hose. 4 benefits on the right, but I want to be honest. The environmental benefits is the one that justifies the whole project. Without SDG 6, this is just another car wash. With it, this is infrastructure. The goal: deploy the 5 pilot modules integrated with Tesla superchargers in Barcelona. The two smart objectives I want you to remember: budget capped at 1 million euros, completion within 52 weeks. On the right, scope: in scope, design, manufacture, install, pilot, application, licenses, environmental assessment, marketing, and closure. Out of scope, expansion, more than 5 modules, long-term operation, post-pilot maintenance. The out of scope list matters. A pilot that tries to be a business at the same time fails at both. Strategy now: strengths, sustainability, innovation, pilot scale, growing market. Weaknesses: Tesla dependency, unproven model, limited operational experience. Opportunities: rapid EV adaptation, weather regulation, no specialized competitor. Threats: Tesla policy changes, competitors, permit delays. The honest part of this slide is the weakness column. We do depend on Tesla. We acknowledged it. The strategy comes from facing it, not hiding it. The PRAN turns the SWOT into action. Play sustainability strengths, reduce Tesla dependency through modular design, enhance opportunities through EU partnerships, nullify threats through formal Tesla agreements and continuous testing. The single most important word on the slide is modular. Designing system to be adaptable to other charging networks is how we convert our biggest weakness into a strategic option. 6 CSFs. I want to focus on the three that matters the most. Sustainability performance 4 liters per wash, 70% recycling, mistakes, and the brand collapses. Reliable charging integration, zero critical safety incidents. This is binary. One accident and the pilot is finished. Regularity approval, permits before installation. A perfect machine is worth zero if the city says no. The other three, adaptation, coordination, flexibility, are important but recoverable. The first three are not. That is the judgment call I made as a project manager. Three scenarios: optimistic, baseline, and pessimistic. Optimistic, rapid adaptation and subsidies. We accelerate replication. Baseline, moderate growth. We focus on operational excellence. Pessimistic, permit delays, partnership disruption. We activate contingency sites and extend the timeline. Most teams plan for the baseline and hope for the optimistic. I think the most I think the more useful exercise is to assume the pessimistic and build a plan that survives it. That principle shaped the rest of the project. Governance: who decides what? Sponsor at the top, steering committee for milestone validation, project manager running execution, 5 specialist leads below. The governing principle is at the bottom: controlled flexibility with strategic discipline. Flexible enough to adapt, disciplined enough not to drift. The RAM matrix. I won't read every cell. The three rules at the bottom summarize it. Sponsor approves the budget and strategic decisions. Project manager owns delivery and risk. Specialist leads own their technical outputs. The rest of the matrix follows from those three rules. Stakeholders by power and interest. Manage closely. Sponsor, steering committee, Tesla, authorities. Keep satisfied. Investors and municipal agencies. Keep informed. Project team and auditors. Monitor public and early users. This matrix stops us from over-communicating with low-power groups uh, and under-communicating with high-power ones. Both mistakes kills projects. The communication plan turns stakeholder strategy into a calendar. Monthly status to sponsor, weekly technical coordination, milestone-based sustainability reports, official documents to regulators. The line at the bottom is what keeps the project honest. Minutes documented within 48 hours. Decisions that aren't written down don't exist. Act 3. What could kill this project? This is where most of my project management thinking went. 8 risk categories, 28 risks total, identified by walking through every assumption in the plan and asking what happens if it fails. The method: probability times impact, scored and multiplied. The discipline isn't in the technique, it's in being honest about the scores. The top 10, 5 risks scored 18 or higher. The dark red ones. You can read this slide as 28 independent risks, but I saw a structure. Look at the top. Number 1, Tesla strategic changes. 2, Tesla dependency. 4, Tesla supercharger integration. 5, installation at supercharger sites. 4 of the top 5 risks share one root cause: our partnership with Tesla. That changed the response plan. Instead of treating each Tesla-linked risk separately, I treated them as one strategic vulnerability with one strategic response. The modular design from the PRAN. The lesson: Risks that look separate on a catalog can be deeply correlated in reality. Reading the catalog as a structure, not a list, is what gives the response plan its leverage. Three columns: prevent, monitor, contain. Prevent: formal test agreements, modular design, legal consultants early, prototype testing. Monitor: catalog reviewed at every milestone, water metrics tracked in real time, critical path monitoring. Contain: Tesla changes shift to non-Tesla sites, permit delays, trigger schedule rework. Tech failure replaces with validated alternatives. And the financial safety net: 180,000 euros of contingency, included within the 1 million euro budget. A plan that only prevents is naive. A plan that only contains is reactive. A real plan does all three. Act 4: Delivery. Make or buy decision. OnDrop EV is a service company, not a manufacturer. So washing systems are bought. That pushes 45% of the budget into procurement. 5 tender packages: robot, water systems, app, marketing, customer service. Our criteria are balanced: cost and technical capability each 25%. A cheap supplier who misses the sustainability spec is a problem disguised as a saving. Quality follows PDSA: plan, do, check, act. 6 KPIs. The two that are really matter: 3.8 to 4 liters per wash, 70% recycling. The other four are important but recoverable. Standards: ICO 9001, 14001, 45001, 26000. Testing: FAT, SAT, UAT with formal CAPA. In a sustainability-driven product, the quality numbers are the product. Transition: how the project hands over to operations. Controlled parallel run model. 6 mandatory go, no-go conditions. Technical, quality, sustainability, safety, regularity, digital. If any one fails, cutover is delayed. No partial handover. Timeline: weeks 40 to 46 parallel run, week 47 final review, week 48 formal transfer. Only certified operators run the models after handover. 1 million euros in total includes not ads, a 180,000 euro contingency reserve. The donut shows the allocation. Procurement 45%, manufacturing and installation 20, technical design 12. The contingency breakdown on the left is more interesting. The largest single reserve, 30,000 euros, is for Tesla strategic changes. The money follows risk. 52 weeks, 8K milestones. Charter at week 2, prototype at week 8, validated at 16, permits at 20, manufacturing complete at 28, installation at 35, pilot operation start at 40, closure at 48. The 15 WBS phases group into 4 stages: planning, development, deployment, and closure. The contingency has a schedule equivalent built into the critical path, not just a money equivalent. There is 4 key takeaways. 1. Sustainability is the business case. 4 liters, 70% recycling. Take those out and there is no project. 2. Risk is concentrated in Tesla dependency. 4 of the top 5 risk. We answer it with one strategic move: modular design. 3. This is a bounded pilot. 5 modules, 52 weeks, 1 million euros. Designed to prove the model, not to build the business. 4. Build to scale. Modular architecture and a replication roadmap mean that if the pilot works, the model travels. Thank you. A sustainability driven innovation only scales if scope, risk, procurement, and transition are controlled from the very beginning. That has been my lens through this representation. Thank you for listening. Goodbye.